Okay, so functions of two variables. So this is going to be some f of xy that is going to map from the xy plane xy onto z. It doesn't necessarily have to map onto z. We'll end up doing a bunch of different variables. And then we'll also talk about functions of three variables. Okay? And so let's just start out with, let's ask about the domain of some of these problems. Okay? So let's say we had f of x y is going to equal the square root of x minus 2 plus the square root of y minus 1. And let's say, well, let's find the domain. Okay? So we're considering within the xy plane, what within the xy plane is actually the domain of this function of two variables. Okay? And now we're dealing with real numbers in this class, so we're not going to consider complex numbers. There's nothing wrong with complex numbers. Actually, I love complex analysis. But we're dealing with the reals in calculus 3. So since I don't want to deal with complex numbers, I can't have either of these square roots being negative, okay? So what does that tell me about the domain of this function of two variables? Well, that means that x is going to have to be greater than or equal to 2, and y is going to have to be greater than or equal to 1. Okay? So if I was going to draw the domain of this function of two variables, okay, well, number 1 and 2, and then I'd go up by 1. And draw this thing like this. And so the domain would actually be that rectangle that just keeps on going out into space. Okay? All right. Let's say we tried to do this as a function of three variables. Okay. So let's say we have f of x, y, z equal the square root of 4 minus x squared plus the square root of 9 minus y squared and the square root of 1 minus z squared. All right. Now, we don't want these square roots to be negative. I mean, we don't want what's in the square root to be negative because we don't want to get into complex numbers. So, what does this tell me? This tells me that if I'm looking at 4 minus x squared, I need this to be greater than 0. Okay? And so, that means that this one would be bounded between -2 and 2. Because if I made it bigger than -2 or 2, let's say I plugged in 3 into this, what would I get? I'd get the square root of 4 minus 9, which would be the square root of -5, which would be root 5i. So that's one of my boundaries. And then for the square root of 9 minus y squared, I'd end up with -3 is going to be less than or equal to y, which is going to be less than or equal to 3. And then for 1 minus z squared, I'm going to get -1, it's going to be less than or equal to z, which is going to be less than or equal to 1. And let's say I'm trying to find the domain. All right, so let's see if I can actually draw this. Okay, so that's going to be my z-axis. That's my x-axis. and this is going to be my y-axis. So my y is going to go up 1, 2, and 3. And it's also going to go back 1, 2, and 3. Okay, and now my x-axis is going to come out now 1 and 2, and back 1 and 2. And then my t is going to go up by 1. Move that down a little bit. 1 and -1. So, what am I really looking at in this domain? I'm looking at a rectangle. I mean, a rectangular prism. It's below the axis. No, not too far. No, not too far. Excuse my not so great artistic skills. Okay. So that's going to be a rectangular prism that just has these boundaries in terms of x, y, and z. Okay. So we can talk about domains within 2 dimensions and within 3 dimensions. Okay. Now let's try to graph one of these functions. So, instead of just finding the domain, let's look at what it actually is. Okay. So let's say we had f of xy is going to equal 10 minus 4x minus 5y. Right? And we're going to try to graph this thing. So now, what is this going to correspond to? Well, that's going to correspond to z plus 4x plus 5y is going to equal 10. Okay? So we have this type of plane right here. Now, how would we begin thinking about how to even graph a plane like this? Well, what you're going to do is start sampling points on the different axes, and then that'll at least give you a triangular portion of the prism, of the plane. And so, let's say I plugged x comma y equal to 0 comma 0. Okay? So if I plug 0 and 0 into this, I'm going to get z is going to equal 10. And then I'm going to say, well, what if I plug x comma z would equal 0 comma 0 into this? Okay, so x is 0, z is 0. I'm going to get that y is going to equal 2. All right? And then I can say, well, what if I plug y comma z equal to 0 comma 0? What's that going to give me? So that's 0, that's 0. And so what would I end up? I would end up with x, which equals 10 divided by 4. So what is that? That's 2.5. Okay? So now I'm going to try to plot this thing. Z is bigger, so I'll make them larger. Okay. So x, y, Z. Okay? So now, this point way up here, what would that point be? That would be the point that would correspond to 0, comma, 0, comma, 10. Okay? And now if I go over the scale, take that point right there. This point is going to be 0, comma, 2, comma, 0. Okay? And now this one's going to go 1, 2, a little bit further, halfway. And this point is going to correspond to 2.5, comma, 0, comma, 0. So it would be the plane corresponding to those points, but then extending outwards even further. Okay. Let's try another one. Some of these get a little bit more confusing. And so if we consider things like traces, let's say we have f of x, y, say equals cosine of y. All right. Okay, so this, what does this really mean? This means z is going to equal cosine of y. Now, when we were thinking about these problems, one of the first things you want to think about is what is really the boundaries in corresponding with z, okay? Because z equals cosine of y, we know that the domain between the range is that -1 is going to be less than or equal to z, which is going to be less than or equal to 1. Okay? So that's going to be the range of that one. Okay? Okay, and then we know that y's domain will be -infinity all the way up to infinity. Right? X is completely free. Will be -infinity all the way up to infinity. Okay, so let's just consider the line where x which equals 0. So we imagine the curve it's a three-dimensional curve, but let's just take one point. Let's take the YZ plane, and we'll just plot it out as the normal cosine way. Okay? So if I just start out, this is Z. And this is y. What am I get? Well, cosine of 0 would be 1. Stand back this way as well. Okay. Now this is independent of x, so let's see if I can draw this. If I went out in this direction, it would be 1 right there, and come up like that, not like that. And so what would this look like? So, and this would extend backwards in that direction and forward in this direction. So this would basically be just not a plane, but a waved surface that would just go off in the y direction and would sort of extend out in the x direction, just like that. That's actually not that bad of a drawing, if I could be honest. Okay, let's try another one, and let's try this one by plotting points, okay? So, let's say that f of xy is going to equal now the square root of 4 minus 4 x squared minus y squared, okay? Okay, so what would this kind of correspond to would be the z squared plus 4x squared plus y squared is going to equal 4. But with a restriction. So, since this is the positive square root of that, we have the restriction on this type of ellipsoid, that z has to be greater than or equal to 0. Okay? So, let's, once again, let's try sampling points that exist on this axis, on the different, the axis. So, if I said x comma y equal to 0 comma 0, what would that mean? That would mean that z has to equal 2. Okay. Let's say I said x comma z would equal to 0 comma 0. Okay. Well, that would mean, all right, so if I set x and z equal to 0, I would get y squared equals 4. So if I take the square root of that, I'm going to get y is going to equal plus or minus 2. Right. Now if I said, okay, I'm going to set y and z equal to 0 comma 0, I would get, all right, so now y and z are equal to 0, so I'm looking at 4x squared equals 4. If I divide by 4 on both sides of that one, I'm going to get x squared equals 1. So x is going to equal plus or minus 1. Okay. So if I try plotting this thing, okay, so I have this point, I'll make it a little bit bigger on this one because I don't have that big of numbers, say 1 and 2. And so I would have the point 0 comma 0 comma 2 being up here. Okay? And I'll take this one out just by 1, and that's going to be 1 comma 0 comma 0, and then 1 and 2, and that would be 0 comma 2 comma 0. I don't want to make this too messy, so I'm not going to plot out the ones on the back and to the left. And so, this would be an ellipsoid. Here's 2. It's going to extend backwards, also to negative 2, and this is a dotted line. It's going to extend back this way. And so what would we end up with? We'd end up with the upper half of an ellipsoid because the square root has to remain positive.